Okay, here we go. Lens and mirror equation. Okay, works for both. Lenses and mirrors. It looks like this. 1 over f equals 1 over di plus 1 over do. Now on your equation sheet, it's going to look like this. 1 over f equals 1 over si plus 1 over so. I don't like the si and so, just me personally, but that's the way you'll see it on your equation sheet. I like the Didot equation. Well, because we know what f is, right? What's f? Frequency. Oh no.
That's what I meant. Focal length.
Focal length is the problem.
It'll work too if you have parabolic lenses or mirrors. Yes, ma'am.
What's n?
All right, hang on. We'll get there. Let me finish this one first. All right, f is focal length. di or si equals image distance. Okay, do or so equals object
Oh, that's so hard.
object distance. Okay? Now, it's not that hard of an equation. You've got this key on your calculator, which really helps out. Okay? Please make good use of this. Like, for instance, let's work a problem real quick.
I usually just use parentheses.
Oh, no. Do this.
You're wrong.
All right, real quick. If I was to place an object right here, if the focal length is 40 centimeters and I place my object 20 centimeters from the lens instead, okay, what kind of image will I get?
Virtual.
I will get a virtual,
Upright.
larger image, this over here, right?
Beyond 2x.
Okay, I'm going to get something back here. It's going to look like
It's
this.
not necessarily beyond 2F, right?
No, not really. It's just going to be back here.
Beyond.
Well,
So you're going to get that.
behind you. So you took
All right?
You took track.
But, well, it's going to be
Beyond that.
somewhere back here behind that, at least. Behind the object. All right, now here we go. Let's solve it. 1 over f equals 1 over di plus 1 over do. I know f equals 40, do equals 20. Do I have to change these to meters?
Yeah.
Okay, as long as you keep a common unit, the units all work out, right? So I'm going to have 1 over 40 equals 1 over di plus 1 over 20. Okay, here's where your calculator comes in handy. Because 1 over di is going to equal 1 over 40 minus 1 over 20, right? Okay, calculator, here's what you do. 40, magic reciprocal button, minus 20, magical reciprocal button, equals, and then reciprocal it again. Invert it one more time.
I just do parentheses and division.
You can do parentheses and division, but this is much faster, because what this does is this produces 1 over 40. This produces 1 over 20. The equal sign gives you what that equals, but that gives me 1 over what I want, right? So then I have to take the reciprocal of that.
Hold on, let's try this out.
What do you get?
Negative 40.
40.
Okay, you get di equals negative 40. Okay, now, 40 means how far from the lens?
40 centimeters.
But 40 centimeters,
Negative 40.
is it that way or that way? Okay, here's where it comes in really handy if you remember that for a lens, if the object is on this side, then real images will form over here and virtuals form over here, right? If your object is here. What if you put your object over here? Then everything switches, right? Because remember, a lens lets light through, so real images should be over here. Backtrack to get virtuals over here. So negative 40, okay everybody, right here, negative means virtual. Positive then means real. Okay? Negative means virtual, positive means real. So the sign is important. You remember every time we have a scalar, the sign is really important because the sign tells you something, like if it's above or below a certain reference point, in this case, whether it's to the right or left of the lens, correct? Virtual or real. In vectors, plus and minus means direction. Okay? All right, now, let's work the same problem for this lens. Okay, everything's exactly the same. I got 40 centimeters to my focal length. I got 20 centimeters to my object. And do we get the exact same answer?
No.
We shouldn't. Okay, so how is this lens different than this lens?
The negative focus.
Yeah, here we go. Right here. If it's a positive focal length, that means converging. Converging optical device. A negative focal length is for diverging. Okay? So when we put this into the equation, what do we put in?
Negative 40.
We put in negative 40 for this one, and that's what separates this problem from this problem. We now have a negative 40 over here. So look what we get. We get a negative 40 minus a negative 20. Okay, so what's our new answer now that we have negatives?
Negative 13.3.
Negative what?
13.3.
Okay, so now we get an image distance over here of negative 13.3 centimeters. So where would that image form?
Between the object and the lens.
Between here and here, right in there somewhere, right? Does that make sense? Should this lens produce an image on this side? That's the virtual side. Does this lens produce a virtual image? Yes, it does. And the virtual image should be smaller, right? Whereas this virtual image is bigger. Okay, so that works out. Okay? Now, let's say you're on a test and they ask you, they give you this exact problem. They give you this problem and they tell you, well, the focal length is 40 centimeters and the object is at 20 centimeters. And then they just have a line on here. And they give you 10, 20, 30, 40 centimeters. And they expect you to draw it all out. They say, draw the object.
Scale, right?
And yeah, it's all to scale.
It was hard.
Okay? So you say, okay, well, the focal length is here and my object is here. What they usually do is they give you the object, but they won't give you the focal point, and you have to mark it on there yourself. Okay? So make sure you mark the focal length where it belongs. And then you got to draw it. But you're not really good at drawing these, okay? So what do?
Get it straight.
You say, hey, I know the focal length. I know the object distance is positive and positive. And I plug it in this equation, and I get my answer to be negative 40. So I know exactly where my image is going to form.
This way.
Right? It's going to form on this side, and when you make your ray diagram, you make sure it shows up there. Now, when you do a drawing, if you're off by a little bit, that's okay. But if you're off by, when you look at it, you go, oh.
My 2C.
Yeah, if it looks wrong, then redraw it. Okay, make sure it shows up where it's supposed to. Okay? You can always know where it's supposed to show up. So always make sure your diagram turns out right. In fact, what a lot of students will do is they'll go, okay, I know it's supposed to show up at negative 40. Well, negative 40 on this would be on this side. So it's supposed to show up right in here somewhere. And they'll just make sure that their drawing shows up pretty close to that. Okay? And you're going to be in good shape. So you will never lose any points on your ray diagram. Now on your ray diagram, how many rays do you have to draw?
2.
Any 2. And then you have to draw your image. Okay? So you'll usually get 3 points. So there you go. Point number 1. Point number 2. And then backtrack. Backtrack. Hey, look, I made it turn out just perfect, didn't I? And then you draw your image. So point number 1, point number 2, point number 3.
It's a bit slanted, but
Hey. They'll never know. Okay? Actually, they might know because they teach their own students to do the same thing. Okay, and that's all right. Okay? Now, focal length. If they tell you that you have a convex mirror of focal length equals 20 centimeters, and you have an object at 40, now let's do it something different, 50 centimeters in front of the lens, okay? Now look, what do I put in my equation?
So we got a negative n.
See everybody right here? 50 goes in here. See right here? Negative 20 goes in here. Because a convex mirror is a diverging optical device. So be careful. They will not always tell you that it's a negative focal length. They'll just give you the magnitude of the length. So be careful, okay? I don't want you to miss those. Okay? Occasionally they'll do that. Sometimes they'll say a negative 20 centimeters. Well, that's fine. Just plug it in as negative 20. But just be careful. Keep an eye out just in case they give you a positive for this type of mirror with light coming this way and this type of lens. Okay? Those both have negative focal lengths. All right?
yes, sir.
Okay. That's our big mirror lens equation. There's one more equation which I have been asked about by Melanie. Melanie said, what the heck is M?
I see it now.
Now you got the big book?
Now that you have the big book, you can see it. Okay, we have one more equation called the magnification equation. Okay, magnification equation looks like this. M equals HI over HO, lending some students to call it the Hi-Ho equation.
Hi-ho.
All right? Or that equals negative Dido. Or if you're into the SI and SO, it's negative SI over SO. All right. Now, we already know what DI and DO are. Positive or negative means real or virtual. Hey, is it likely that they'll ever give you a virtual object?
Got it.
No, but you can have a virtual object. Let me show you how. If you have a lens like this, and it's just like the one we just did, where you have your object up close and it forms a virtual image back here.
Yes.
Okay, that virtual image, if you have another optical device out here, that virtual image becomes the virtual object for our next optical device. Ooh.
So you reverse the rules.
No, you just put it in. Your object is
Well,
now
if
as a
it's-
negative distance.
So, yeah.
All right. I'll show you multiple optical devices in just a second. All right. Okay, HI and HO.
Hi-ho.
That's height of image and object. Now, please, height means size. So it could be diameter, it could be length, it could be any kind of one-dimensional measurement of the object. Okay? All right? So radius, whatever. Okay? So height of the image, height of the object. Hey, so wait a minute. What would a negative and a positive mean here?
How do you have a negative?
Period. That's
It's
it.
just below.
So
the
positive means upright. Negative means inverted. Okay? So negative height means inverted. So if you get an answer that's negative, that means it's been flipped over. Okay? That's all it means. Piece of cake. All right, so let's talk about magnification. If the magnification is 3, what would that mean?
image is 3 times larger.
The image is 3 times larger than the object. What if you get a magnification of negative 3?
It's inverted.
It's 3 times larger, but flipped over. Okay, what if you get a magnification of 0.5?
It's half as large.
Half as large, but upright. Okay, so this would mean half as large and inverted. If your magnification is 1, actually, if you have a magnification of -1, which mirror are you using, and where is your object located? At C,
Concave mirror.
and it's concave. Very good. So for a concave mirror at the center of curvature for your object, you'll get this type of image. Same size, but flipped over. All right? Excellent. All right, that's it. Okay? Oh, wait a minute. That's not it. What if you have multiple optical devices? I think there's one on your homework somewhere, wasn't it? Or on your packet?
On the packet it is, I don't know.
Okay, here's how this works.
There's one right there. Clear that one.
Say you had something like this, and we'll make it easy. We'll have our object right here. Okay, so we got our house right here. Okay, so all you do is you go. Okay, now where is it supposed to show up?
At 2F.
Okay, so where do I draw it? At 2F. Now
Same
mine's
size.
larger than it's supposed to
Should
be,
be
right?
same size.
Should be the same size. So I messed mine up
Bad.
as I freehanded. Thank you, badly. All right, now what do? The image of your first lens becomes the object of your second lens. So now you go straight in, it bounces out from the focus, you go toward the center of curvature, and you bounce one straight back, and so my house is going to show up right here. Okay? Hey, now that's a good question. What kind of image is that?
Virtual.
It's virtual, but it's inverted.
No, it's the same. No, it's the same as the.
Yeah, it's not inverted. It's inverted from this one, but it's not inverted from this one, right? This one's below, that one's below. So this is an upright image of that. This is an inverted image of that. Okay? So all you do is just follow it through one after the other. Okay, how likely is it that they'll give you one of these on the test? Yeah, it shows up every once in a while, and usually it's the last question on a lens or mirror problem. And usually you just have to draw it. What if they ask you to use equations? Then what you would do is you would use this equation to figure out where that's located, and then that one now becomes the object for that one. And then you would just work it again, where the image from before becomes the object in the next one. Okay, not a big deal. Let's work a couple. All right?
Oh, you said convex. Okay, I got it. -15.
All right. You have a convex lens, focal length 20. The object is 60 centimeters from the lens. What's the distance to the image?
Go.
Convex lens.
That's negative. So that means focal length is
Okay.
negative.
No.
It's positive.
Okay. Oh, I erased them all.
Yeah, no.
Okay, remember, focal length is positive for this type of lens and this type of mirror with light coming from the left. Negative for this type of lens and this type with light coming from the left for a mirror. So remember, concave and convex get us messed up. This is for converging, this is diverging. All right?
How tall is the object?
I don't know how tall the object is. You want the height of the object?
Yeah.
Say the object has a diameter
So you can find the magnification, you know?
of
the idea.
Oh, yeah, that's right.
4 millimeters.
Oh, that's a midget.
Yeah, it's a midget. You're looking at something small.
Wait, I got 30.
I don't know. I just made it up. Yes, I said diameter on purpose because, remember, height just means a size, right?
30. Negative 45.
Okay. Problem number 1. Convex lens, focal length 20. Okay, so decide real quick. Focal length, positive or negative? Okay, positive because we're talking this kind of lens. Okay. So that's always positive for my object. We're not going to have any virtual objects. So this is going to be 1 over 20 equals 1 over di plus 1 over 60. So what does di become?
30
30 what?
centimeters.
Centimeters. Okay, for magnification. Now remember, magnification equals hi over ho, but I don't know what the height of the image
No,
is.
DI.
But I know negative di over do. That becomes negative 30 over 60. So it's negative 1/2 or 0.5. So what happened to my image? It's inverted and half the size. Now does that make sense?
Yes.
If you place an object 60 centimeters away from this kind of lens,
And it's closer.
so you're beyond 2f, right? So it should be inverted and smaller, right? Excellent. So what's my height now then? Negative 2 millimeters. Why negative? It means it's inverted, and 2 millimeters means it's half the size it was before. Got it? All right, now let's go over and do this one. Work this one out. Ah, but. Oh wait, I'm sorry. Back up. Here, so back up. Let's do this first. There's the one I had. Lens. If I do this for a lens,
20.
then that should be positive, and that's 20. So wait a minute, that's 2f, right? So my object distance should be at 2f on the other side, right? So this should be 20. The height should be negative 1. Magnification should be negative 1, right? Okay, let's make it more challenging. Mirror. Okay, first things first.
Negative 6.6.
This.
Negative.
Negative. Why? Because it's this kind of mirror with a negative focal length, with light coming this way. All right, so I've got 1 over f equals 1 over di plus 1 over do. So that's 1 over negative 10 equals 1 over di plus 1 over 20. So I get 1 over negative 10 minus 1 over 20. Put them together, flip it over, and I get negative 6.67 centimeters. Okay, so what's my magnification?
Negative
Negative di over do.
0.33.
So negative 6.67 over
20.
20. Thank you.
Positive.
But it's a
But that's negative.
0.33.
So it's 0.33. 0.33. So wait a minute. That means it's positive. What does that mean?
It's upright.
Upright, but shrunk to 1/3 the size.
Yes.
So the new height then should be 3.3. Oh, no.
0.33.
0.33 meters then, right?
centimeter.
I think I put meters.
Okay.
All right, so there you go.